When you take a step forward, your foot has forwards force as your heel strikes the ground, shown by the green arrow. The ground then exerts a frictional resistive force in the opposite direction back onto your foot, which is Newton's third law: equal and opposite reaction. This friction force is what keeps your heel in place on the ground, allowing you to then transfer your weight onto the forward foot. You begin to move forward as your back heel comes off the ground, and you drive through your back toes, shown by the green arrow pointing to the left. Your back toes then exert a backwards force on the ground, and the ground in turn exerts a friction force in the opposite direction on your toes, in the forwards direction. This is how you're able to walk forward, because the friction force actually pushes your back foot forward and allows the completion of the weight transfer onto your front foot. That's why if you try to walk on ice and you take a big step forward, you have the same forwards force as you did when you were walking on a dry surface. There is very little frictional force from the ice to counter the forwards force of your front heel, causing you to slip forward. This is shown by the blue arrow, which is the frictional force from ice, significantly less than that from a dry surface. Also, with your back foot, there's not enough friction for you to counter the backwards driving force of your back toes, causing your back foot to slip backwards. If you try to walk on ice, you'll essentially cause yourself to do a split. Now, hopefully this will give you an appreciation for how friction allows you to walk, and you can understand exactly why you should never take big steps on ice, because this is exactly the situation that would happen.